Okay, so afternoon everyone. I'm Ziran Sang from open source group Samsung Research UK. Today I'd like to talk to you about IoT.js. It's a JavaScript platform for Internet of Things. So before the talk, I'd like to show you the light demo. There a little bit. I was planning to do the real demo. Unfortunately, this laptop has a little bit issues connected to my access point. So I'll show you video first, and then later, if we have time, we get connected. We'll show you more, hopefully, in real. Then we'll go after the demo. We'll go behind the scenes of the demo, and we're going to introduce you the platform IoT.js itself. In the demo, we actually introduced the Blink-T module for the light here. So we're going to show you how the JS code was written for this module, and also walk you through to integrate this module into IoT.js platform. So for the demo part, sorry for it might be a little bit disappointing, but I'll just show you the video first, and then hopefully we have a chance to do some more later. Short demo I will explain later. So it's quite simple, the demo. What I have here, actually inside this case, I have this Raspberry Pi. Show you the architecture first. I have this Raspberry Pi 0W board, and we have actually, and this is an array of GPIO port, and we have this one row of 8 LED light, which is actually like a hat mounted on the GPIO port. So the Pi itself is about 512K RAM, and I think that the flash I have actually here is 16 gig. We did have 8 gig runs, but this doesn't matter because it's plenty for running IoT.js and JavaScript on it. To be honest, the JavaScript is so much small. We're actually targeting like under 128K for RAM, and for Flash is actually under 1 meg. So it's quite impressive JavaScript engine. And in this board, this board runs Raspbian, the Raspberry Pi Linux distribution. Then we install the IoT.js. IoT.js is repository. You put the source actually has not only has the platform itself, it also has JavaScript, the ultra lightweight JavaScript engine, and also we also have this event I/O controlling, event I/O handling library, libTUV. So, and then on the top of the platform we have our demo, and the demo code actually based on the Blink-T module we introduced into IoT.js platform. So the scenario for this demo, very simple. So what you do is the demo app pulling the current weather data through cloud API, so the data actually provided by openweathermap.org. So we're actually calling API, the API actually provided by them, and then we're actually using user authentication code to get the data. You need to register your app to the third-party organization, and then upon the data received, and the app will decide whether to turn the light on, off, or change the flashing patterns. The use case for this really, because my colleague did a street light demo before last year, so we're thinking like this is a really good idea. You upon the visibility, the data current visibility you have, and then you turn the light on off. Considering a smart city situation, how much energy you're going to save? And just actually what you need, obviously, this light but just with a small chip like this, 5-6 pounds, you know. So the app itself, because the app itself actually using the typical, actually the generic APIs provided by IoT.js platform. So pulling data from a third-party cloud, we use HTTPS request, and then controlling the blinking light, we're actually using the GPIO APIs, which provided by the platform itself already. So the whole demo actually, I think it's worth mentioning, but including the module we introduced, Blinky Light module, and also demo apps, they are fully in JavaScript. So why JavaScript? Can I ask how many of you are JavaScript developers? See, this is the reason why, because we have a big pool of developers here. And the other reason is safe, because I think in JavaScript you can't, they have control on memory access. So for manufacturers, if they don't want you to access their memories, JavaScript probably is one of the good options. So this demo basically is based on IoT.js. What is IoT.js? As we mentioned earlier, it is a platform. It's an IoT platform. It's enable you to use JavaScript to write your IoT applications. And the platform obviously based on web technology, but this platform actually heavily rely on the engine running under it. That's JavaScript engine. So when we design this platform, we actually have bear in mind the success story of Node.js. So the architecture itself is trying to be as close, as friendly, as much to Node.js. And on the other hand, we try to make the memory consumption as less as possible to fit more constrained devices. Obviously, the web we run here is JavaScript application, and as you see, that is actually be able to access HTTP, it's be able to access GPIO. Obviously, there are a lot more modules that actually already been provided by the platform itself, including file system, night, and a lot more. I will show you later. So this is the architecture of IoT.js. Two things actually. As I mentioned before, when you download the source itself, the platform source itself, you actually already have JavaScript and libTUV included. JavaScript is the rock for IoT.js platform. It is ultra-light engine, so the binding from the platform to ECMA script really depends on JavaScript. And libTUV is actually refactoring of libUV library that used by Node.js. So we refactor and make it use less memory consumption, better performance for embedded system. And we are trying, at this moment, we're discussing on IoT bindings to different platforms. One of the options is OCF, Open Connected Foundations activity, because we have been involved in activity before, still involving, I guess, yeah. And that's one option, but obviously we actually consider other popular used IoT platforms. So the core of the IoT.js actually basically native C code, and on the top, when we wrap it up into a set of JavaScript APIs, and apart from these APIs, we provided the architecture itself is very modular. So a set of modules like file system network. This is quite similar to Node.js. So as a JavaScript developer, to be honest, you probably don't need to worry too much about underlayer. What you need to do is just go call the JavaScript APIs. So mention the rock for the for IoT.js is JavaScript. We actually, from the group, we have presented JavaScript in last couple years. It's really very good, compact, lightweight engine. So this JavaScript was designed from scratch by Samsung. Initially, from the beginning, the design aim was to make it for constrained devices. So this idea is always through. Even the name Jerry actually comes from the Tom and Jerry. So it's yeah. So it's small and smart and fast, hopefully. Yeah. So the optimization work for this engine has been really continuously. Even last year, we actually have about another 100% improvement of performance. This is always the JavaScript top priority. Reduce memory footprint, increase performance. And the engine itself is really self-contained, very portable. So you might see other places, IoT platform also use JavaScript. So the latest status for JavaScript is it's been transferred to JavaScript Foundation in 2016 under big umbrella. And some new features introduced, I think, last year. Yeah. So we have a debugger for JavaScript. The JavaScript debugger, you can use a command line. If you're familiar with GDB, you probably don't need to go through any menu. Just whatever GDB has, you can use straight with the command. And also there is Web IDE debugger. So, it's just allowing you to, using UI, set up your breakpoint and work through your code. Yes, JavaScript actually been fully in line with ES 5.1. So we passed all the confirmation tests. So now some new features have been introduced in ES 6, including promise, type array. But we're very careful introducing new features because there is a balance on rich features and lower memory. So, but this is the ES feature further work is going to be carry on. More feature will be introduced. And last year, especially last year, JavaScript actually got a lot more. Last couple of years got a lot more interest. Especially last year, we got a lot more contributions from other, community members, and which actually result a lot more hardware board support, like ARM and Band. So the latest status for IoT.js is that the big milestone is released, stable release actually 1.0 in July last year. And as we seen earlier, basically has a libTUV in it, and the modular system. The modular system basically has two layers. One is on the native level, so it's C code. So if the code actually structure is very tidy and clean. So you go inside, you see the native code, actually each module very tidy listed. And then you go to JS direction, you can another list of module in JS format. And the Node.js Node.js friendly architecture, which libTUV is very good example. And we also introduced a big subset of Node.js, like a file system, HTTP, actually HTTPS, I just used that early. It's not fully supported HTTPS, not every feature is fully supported, but this HTTPS request is definitely working. I can confirm that. And actually support this subset of Node.js module actually is really make the developer's life very easy. If you are very familiar with Node.js development, and some of the code, if we support the same module, you can just seamlessly using the same code from IoT.js, probably most of them without any modification. And obviously vice versa, most of the sample code in IoT.js you can use in Node.js. And obviously a list of I/O control, like I use the GPIO, and we also have I2C, SPI, quite a few other support. So from developer point of view, I look at this Blink Light module. So the Blink Light module basically what this actually is quite popularly used in a lot of demos, this light. So we look at what's available. Actually, there are Python code obviously available. And the good thing is Node.js also have this NPM module. So for us, actually, the natural point obviously starting with Node.js module and see also one way to check the capability for us. So the module itself, we check the Node.js code. It's actually quite straightforward. The only difference we need to change is how to access GPIO port. And Node.js Blink-T module using this another library. It's VariantPy, if you're familiar with VariantPy library. VariantPy library basically provides the native access for GPIO for Blink-T. But in our case, actually, it's so straightforward because the IoT.js platform already provided the API for GPIO access. So the example really is like for us, to control the light, really we just need to configure two GPIO ports. One is for data, the other is for clock. So just call the APIs straight away like this, configure the APIs. The next part is to write your data into the write your data with the latching line on/off. Yeah, I think this is really pretty much it. Quite straightforward. And after you have your own module library created and then integrate to IoT.js, really just add your module into the file, the JSON file, and then get a build enabled when you build it. So it's really straightforward, really. So to wrap up, really, So what I have here is IoT.js platform. It's a JS platform for Internet of Things based on JavaScript, the ultra lightweight JavaScript engine, and create your own module library to the platform. Really, just a few steps away. So we really hope if you're a JavaScript developer for IoT, we hope you crack on and enjoy using IoT.js. Thank you.
I'll just try some questions.
I can do questions actually.
Maybe a reboot could help. I don't know, with the Wi-Fi.
Yes, yeah. But like questions is fine.
Yeah,
Let's do
okay.
questions.
Let's do a few questions and then maybe try to connect to the Wi-Fi and give the demo anyhow. So, who has any questions?
Do we have any?
That doesn't connect anything.
Can you explain?
Yes, yeah,
Do
question.
you have any idea of the smallest microcontroller that could run JavaScript?
Yes. Yes. The question is really how small the memory footprint for microcontroller when you run JavaScript, right?
Yeah.
Yeah.
Yeah. How does it compare, like, to if you were to write the similar code in C? Like, do you have any ideas of benchmark and things like
The
that?
benchmark to compare this the code you write in JavaScript with C, native code of C, right?
Yeah.
Okay. First thing is the footprint for JavaScript. We had a build actually under about 200K.
Okay.
So it built for ARM Sum 2, so it's about 143K. So really, you don't need much memory for that. Compare with C, we haven't I haven't come across any comparison with C native code. But there is a reason, because it's JavaScript. because if you think about, we're actually using C code under, and then we wrap on the top with JavaScript. So there must be, just even with the same platform, using C code access the hardware, and then you're using the same C code, but on the top you wrap up with JavaScript. So I would assume that it will take more memory.
But do you know how much, or do you have an idea?
I actually haven't got the idea, but considering how much JavaScript already, how small it is, yeah. Okay.
Seem to connected.
Yeah. Okay. Let's see how it goes. Yeah. Okay. Yeah. I can do more questions.
More questions?
So the reason you got onto Raspberry Pi is to show that you can run this in this widely available.
It's a very good question, actually. Why we use Raspberry Pi? Because we already had we can support such a small microcontroller. Because of the popularity of Raspberry Pi. That's the main thing. But of course, we welcome to you. If you try on small controller, and we welcome to, if you have any experience, share with us. We will really appreciate it. Yeah.
Does it support SPI and I2C? It's got all the usual support for all the usual stuff that they have in microcontroller.
Say it again. In the microcontroller.
All the interfaces.
Yes, yeah. It's actually support quite a few different boards. Yeah, microcontroller. Yeah. Obviously, as we said, that JavaScript is modular. Is a modular engine. So when you build it, actually you link to whatever module you need. So don't build it with everything in. Yeah. Okay. So. Probably mistype it. Yeah. Let me just, since this is connected, let me just run you through the demo. So watch the light, hopefully. Here we go. Yeah, it's quite lovely actually. Because yeah, thank you very much. Thank you.
We can do one or two questions if you want.
Yeah,
We still have
sure,
some time. So
sure.
there's still some time for one or two questions.
So for people who really care about the footprint of the performance, is it possible or advised to write the module in C and then just create a JavaScript wrapper if I want to?
That's possible. Yeah, yeah. You can fiddle the C code anyway.
Right.
Yeah. Yeah.
One more? You know, if there's still one question? Yeah.
I saw Tizen. How does IoT.js relate to Tizen?
IoT.js it supports Tizen RT.
Yeah.
That's my colleague. He, Phil got IoT.js runs on Tizen RT. Yeah.
All right, great. Thank you.
Thank you very much.